This is the IMC Holding Company plastic model assembly kit of the 1885 Benz Patent-Wagen, finished April 9, 2026. The company is based in Ukraine. It is 1/24th scale and is very detailed. The model requires detailed painting and careful assembly of very small gray plastic parts. Wiring, piping, and the coil box under the seat were added separately. It is a wonderful educational assembly. By taking the time to research, you can learn everything about the story and engineering of the very first car. The script and images of this model were written and completed by John D. Sautner, April 9, 2026. Any use and sharing of this content is fully encouraged. Please share. This is a video explanation of how the invention of Carl Benz in 1885 was engineered and operated. Carl's wife, Bertha Ringer, played an important part in the successful launch of the Benz Patent-Wagen. It was Bertha's dowry inheritance that financed Carl's businesses and inventions. It was Bertha's critical involvement with the assembly that helped bring the car to life.
German engineer. Nicholas Otto is generally credited with inventing the first practical, four-stroke internal combustion engine, the Otto cycle, in 1876. While earlier prototypes existed, Otto's design was the first reliable, compressed charge engine, paving the way for modern automotive engines.
The components and designs of this car are still used in every internal combustion car on the road. Today, there are over 1.6 billion cars on the road. In 1885, there was only one, this Benz Patent-Motorwagen. Social media in 1885 rumored that this magical self-propelled wagon was the work of witchcraft. People called Carl and his wife Bertha witches, and they said Carl was the devil himself. Replacing the horse was ridiculous. Bertha would go on to showcase the car's ability by making the very first long-distance journey to her mother's home with her two children without Carl knowing. Her mother's home was 100 kilometers, or 60 miles away. She traveled through forests on dirt and gravel trails. The trip was treacherous and required stops for maintenance and refueling. Bertha wanted to prove to Carl and the world that his invention was worthy. The car's maximum speed was 10 miles per hour and took over 12 hours to complete the trip to her mom's home. Bertha later took the car to the 1889 World's Fair in France. Fortunately for us, this very first car changed the world we live in. Before we take a seat on this car and drive it, we need to inspect it, prepare it, and top up all the liquids. First, we must look at the mechanical, wiring, and piping connections to make sure everything is secure. Second, we must top up the water in the canister above the engine block. Water enters the engine block by gravity. The top pipe on the canister is for allowing air pressure into it and letting steam and water overflow to come out of the pipe under the chassis. The bottom pipe is for circulating the water into and through the engine block. Third, we need to top up the oil cups over the engine block and over the push rods. Fourth, inspect the engine block that was cast in 3 sections: the top valve cover, the middle combustion chamber, and the bottom crankcase. This engine was a single-cylinder, 4-stroke engine, weighing approximately 100 kilograms, 220 pounds, and producing roughly 0.75 to 0.9 horsepower at 400 rotations per minute, RPM. No gaskets were used between the 3 sections of the engine block when they were bolted together. Due to the low pressure, low speed nature of this early internal combustion engine, traditional high pressure head gaskets were not required. Sealing was achieved through precision fitted metal surfaces. Fifth, check that grease fittings and nodes have grease and are pushed in place. Sixth, top up the fuel in the small fuel tank. Open the lever valve located on the fuel line under the tank. The carburetor is a small canister connected to the fuel tank by this fuel line. The car used Ligroin, which was a petroleum-based solvent used for cleaning, sold by pharmacies at the time. On Bertha Benz's historic first long-distance journey, she had to stop at a pharmacy to fill up on Ligroin. Today, you can visit the historic first-ever gas station in Germany. It is a popular tourist destination complete with the 1885 pharmacy and how it looked back then. There is a statue of Bertha and her children on the Benz Patent-Wagen. The route was preserved and you can drive it today. There is also a replica car on the site to see and ride. Seventh, check the carburetor setting for startup. The throttle or brass rotary knob is located under the driver's seat and needs to be pulled out to expose one hole in the multi-hole pipe entering the carburetor. This will choke the air in the fuel-air mixture for startup. Once the engine is running, the rotary knob can turn completely open and allows more air into the carburetor. 8th, check the electrical system. The 6-volt battery is in a large wooden box, and the battery is connected to a high-voltage trembler coil or vibrator ignition. The coil is connected to the spark plug and has a circuit breaker, electricity distributor, located at the drive shaft. The negative side of the battery was grounded to the metal chassis and engine block, so the metal spark plug housing would have a negative common ground. Today, you see this as the thick black cable coming off the battery. An interesting side note, the battery is the invention of Alessandro Volta in 1800. He replicated the chemical reaction of the inside of a fish or eel that sent an electrical shock to predators. Volta used alternating pairs of copper or silver and zinc discs separated by absorbent material, leather, pasteboard, or cloth, soaked in an electrolyte like salt water or acid. The elements could be set in a glass jar and piled on top of one another, with a wire coming from the ends of the pile, positive and negative. He patented his battery as the Volta pile, and we named the measurement of electrical potential as volts. Today, there are billions of batteries in use. The coil was in the smaller wooden box below the seat. The coil boosted the battery's voltage from 6 volts to 3,000 volts. A higher voltage is needed to cause the spark on the spark plug. In 1831, Michael Faraday experimented with the new discovery of inductance and electromagnetism and built the first coil, Faraday's iron ring. Bertha used the flywheel on the end of her sewing machine to spin wire into Carl's version of the coil. It is interesting to note that Nikola Tesla's coil came 6 years later and was patented in 1891. Under the seat above the brass rotary knob was a turnkey that closed the circuit to the coil/battery. This key needs to be turned to close the circuit. Finally, we need to inspect the electricity distributor to make sure the connections are working and we get a spark. The distributor was a short, flexible steel band that operated like a Morse code key. A cam lobe was on the drive shaft that would push on it to close the circuit and then release it open as the axle spun. We can test to make sure we are getting spark by pushing down on it with our finger and listening for the rapid fire of the spark. This ignition was a trembler or rapid fire spark that sparked when the piston was in the compression cycle, top dead center. Since accurate timing was difficult to align in 1885, Carl designed the spark to rapid fire instead of today's single fire. Another interesting side note, the Wright brothers Flyer, the very first engine-powered plane in 1903, used a magneto on the crankshaft to develop a high-voltage electromagnetic static charge to create the 3,000-volt spark. Plane engines use the magneto spark system. Your lawnmower engine uses a magneto to create the spark too. The Wright brothers engine was home-built with help of an engineer and modifications to cooling and fuel delivery. However, Benz's engine technology was replicated to build it. Just no need for the battery and coil. Now we are ready to start the engine by manually grabbing the outside of the flywheel with one hand and spinning it hard. The flywheel served as a circular momentum keeper. It was a way to add angular kinetic energy to the system and keep things going by inertia. The flywheel is still used on all internal combustion engines today, located in front of the transmission. The downstroke of the crank pulls the piston down via the piston rod. The piston moves down the cylinder inside the engine block, sucking the fuel-air mixture from the carburetor canister to the combustion chamber through the open intake valve inside the engine. The two valves, intake and exhaust, are controlled by the push rods on the side of the engine block. The flywheel will spin on its own, completing the second compression stroke and firing the spark, causing the explosion of the fuel-air mixture. This forced the piston back down as a power stroke and hopefully starting the motor. The process may take a few tries. The fourth stroke of the cycle has the piston pushing back up and forcing the exhaust out of the chamber through the open exhaust valve. The exhaust went out the short exhaust pipe located under the engine block. There was no regard for the harmful byproducts of internal combustion in 1885. The Benz Patent-Motorwagen engine produced a loud, rhythmic rattling, thrumming, or hissing noise, often compared to a hit-and-miss engine. The 0.75 horsepower single-cylinder engine was slow-firing, sounding as if it might stall at any moment while emitting a distinct, pungent smell. Another interesting side note, spinning the flywheel can be harmful if you are not careful to stay clear of it when the engine goes on its own. A hand or arm inside the flywheel can cause serious injury. Later vehicles adopted a hand crank at the front of the car. Many injuries, even deaths, were reported to car manufacturers, caused by careless use and engine backfiring. In 1911, Charles Kettering of Dayton Engineering Laboratories Company, Delco, developed an electric starter, using the Tesla electric motor design to eliminate the need of a manual crank. Now, you just need an ignition key or finger-operated button, a fob. Motorcycles come with a foot crank or kickstart to achieve the same startup process. However, most now come with an electric motor start. Charles Kettering developed the electric starter at the urging of Cadillac's Henry M. Leland, following the death of a friend, Byron Carter, that was caused by a hand crank backfire. It is believed Kettering saved many lives and limbs. Now the engine was ready to drive the wheels using bike chains and a drive belt. The drive belt was a leather belt commonly used in steam-powered engines. It is connected to two pulleys in a figure-8 fashion to avoid slipping off. One pulley is on the drive shaft of the motor, and the other is on the wheel axle under the car. The belt was sewn together with strong wire and at times needed repair from local shoesmiths. The Benz Patent-Motorwagen featured a rudimentary brake system consisting of a manually operated lever that engaged leather-covered blocks against the pulley belt. It lacked foot brakes, relying entirely on this hand lever to slow the vehicle. Bertha Benz famously invented the first brake linings in 1888. The steering mechanism did not have a steering wheel. Instead, it used a tiller system. This was a vertical lever with a handle, acting like a boat's rudder to turn the single front wheel through a rack and pinion mechanism. Rack and pinion, meaning that turning the steering rod used a gear to push or pull a rack stem connected to the front wheel. Rack and pinion turning systems are still used today. In modern cars, power steering assistance via an electric motor or a hydraulic pump is added to the rack and pinion system to make turning a car easy. Today's cars weigh an average of 2 tons. It is easy to understand why Carl was concerned about people wanting his invention. Because of the complexity of the operating systems and high probability of failure, he was convinced no one would replace horsepower. He was wrong. In 1889, his cars were sold at a high price and often required a mechanic to be readily available. They did sell. Many other car manufacturers and competitors began replicating his invention. Henry Ford famously bought one of Carl Benz's motors in 1896 to build America's first car, the four-wheeled quadricycle, and so began the American Revolution of the automobile. But most notably, a German competitor, Gottlieb Daimler, in 1890, started a car company. After World War I, in troubled times, Benz and Daimler merged, and Mercedes-Benz would become the #1 car company in the world. So, hop on the seat and let's go for a ride.